Yes, good morning guys to all of you. Please tell me, am I properly audible and visible to all of you or not? And guys, today we have a wonderful session on welding, and we would be completing this welding within 2 to 2.5 hours. Okay, and we are going to revise all the concepts quickly from the welding. As you know, every year one question for 2 marks is coming from this topic, so it is important. So with this 2 hours of session, if you can get 2 marks, what else you need? Yes, Gokulnath, Shruth, Vineet, Shyam Sundar, Pattipati, Naveen, I welcome you all and good morning guys. So without wasting the time, we are starting the session. So guys, this is some detail about me. My name is Dheeraj Sardana and I am having around 10 plus years of experience. And today's topic is related to the production. Yes. So guys, we are starting. And this is one more information, those who are preparing for GATE 2024. So guys, I am going to take a mega workshop for the strategy to be in top 1% for GATE 2024 exam. Tomorrow 12:30 p.m. will be the time. So tomorrow is New Year also. So on this New Year, you can take that pledge if you are talking about 2024. And I will be telling you how you can be in top 1%. Because top 1% are going to be either in IITs, PSUs, IISCs, like that kind of institutes. So guys, that is what is the dream of the students. Okay. So guys, if you want to register for the workshop, if you want to register for scholarship test, if you want to download the ebook, just go to the description of this session. Okay. Shubham, Manas, Shreyas, good morning to all of you guys. So now we are starting the session. So this I have already taken many times, production versus manufacturing. Then we will be going for the welding. So you already know when we are talking about production and manufacturing, manufacturing and production are same with reference to the mechanical engineering, same with respect to the mechanical engineering. But in general, when we are talking about production is a very big field for which manufacturing is a small part. Okay. So I already told you production word is used everywhere. Like whenever you see any movie, so in the movie you are always saying the cast, star cast. There you see produced by. You will never see manufactured by. I told you we are the production of our parents, not manufactured by our parents. So likewise, production is a term which can be used everywhere. But for mechanical engineering, both can be treated as same. Okay. Then my dear, today our topic is going to be the welding. So first of all, you must understand what is welding. When I was teaching you, very good, Shubham. So when I was teaching you casting at that time also, I have shown you some kind of laboratory method, what you are going to do in the casting. Here also I am showing you an animation, which is showing you how you are going to perform the welding. This will help us. But first of all, let us see what is welding. Welding is the process of joining two metals. And when we are going to join those two materials, they may be similar, may be dissimilar. And when you are joining them, you may be using the effect of heat or effect of pressure. You may be using some kind of filler material or not. So it is the process of joining two material in such a way with the application of either heat or pressure or both, with or without the application of filler material. This is how the welding is defined. Umar, good morning dear. So when we are talking about this, in the college you have seen this kind of welding, which is said to be the arc welding. You must have taken two plates. Good morning Amir. You must have taken two plates. Those plates were kept together, like you will see. And when those plates were kept together, you can see here, plates were kept together. And after that you were having an electrode with the electrode holder. And from that some flux amount was going on and the welding was taking place. But you were not that much perfect in welding. That is why when you were doing, sometime you were having that electrode was sticking to the workpiece. Sometimes you have seen welding was not initiated because of the gap is more. So that all the things we are going to discuss now. This is just a process I have shown you. You have seen in the welding lab, in the manufacturing lab in the first year. Sir, you will take forming same. Yes dear, I am planning for the same, and for that I have already planned. I feel we can go for one topic tomorrow and one topic on Monday. Okay. Then from Wednesday onward, Wednesday I am going to take strength of material for that. So we will be revising entire mechanical engineering. Abhishek, good morning. So now we are starting the process. Okay. So my dear, now I will be teaching you everything from the basic, like in the last time. What we have done, first of all, I have shown you the lab, what is going on. So I have shown you that. Now we are talking about, first of all, weld bead geometry. So whenever you are going to weld, after welding, you are getting this kind of thing. Okay. So my dear, in this weld bead geometry, there are three parts. First part is this hatched part. So this hatched part is given the name of weld bead. This is the part which was initially not there. Initially you were having only the plates. So this is said to be weld bead. And this weld bead also have the two parts. One part is which you can see below this red line, which is you can see inside the plates. This part is given the name of penetration. And after that the above part is said to be the reinforcement. And guys, you have seen in the previous figure, after welding is over, in the reinforcement we are having a layer of slag which is removed after welding. Okay. So my dear, that is why some part of reinforcement is generally removed by the machining process. But this penetration is going to be the part of this complete welding. So this is the penetration part. And my dear, as you are using, when you are doing the welding process, you are taking the use of heat or pressure or both. So my dear, some nearby region are also affected by that heat. You must have seen that when you are talking about heat, you were using the heat or pressure or both for the welding. So when you are using these things for the welding purpose, obviously at the time of heating, nearby region would be affected. So the region which is affected by the heat of welding, that region is given the name of heat affected zone. And this zone is very much near to the weld bead, you can see. After that, this part which is not going to be affected by the heat of welding is said to be unaffected zone. So my dear, and if I'm going to make a tangent onto the reinforcement part, I can make a tangent like this, then this would be an angle. This is said to be the angle of convexity. It somewhere gives the idea about reinforcement, how much it is. So angle of convexity. Okay. So guys, this is, I have just defined the geometry, weld geometry. Okay. Very good, Amir. So I would ask you that we have discussed here the three portions. One is heat affected zone, unaffected zone, and weld bead geometry. If I ask you out of these three, which is having more strength, which is having least strength, that kind of discussion I have done many times in the classes on YouTube. So I would like to ask you, out of these three, which do you feel is going to have more strength and which do you feel will be having the less strength? Yes, please answer, all of you. Very good, guys. So as per your answer, you know weld bead is having the highest strength, and my dear, unaffected zone nahi, heat affected zone would be having the lowest strength. I would also give you the reason for that also. Very good, Deepak Yadav, Shyam Sundar, बहुत बढ़िया, Naveen, Surendra Singh Solanki, बहुत बढ़िया. So guys, out of these three, I can say one thing: weld bead is having the highest strength. Weld bead is having the highest strength, and heat affected zone is having the lowest strength. Okay, and this is going to be intermediate strength. Okay, intermediate strength. Now you would be interesting to know that why it is happening. So you have seen when the welding is going to be formed, you are joining the two plates and you are having the electrode. Due to heat, electrode is melting and also plates are melting. But on the electrode, we are having some flux material. On this electrode, we would be having some flux material which is different than the metal. So because of that, when this electrode would be melting inside the groove for the weld bead, it would be making an alloy. And you already have studied that alloys are stronger than pure material. So that is why weld bead is having the highest strength. Then my dear, why heat affected zone is having the lowest strength? In the material science, you must have studied about heat treatment. Heat treatment are the processes in which we heat the metal up to some temperature, then we hold it for some particular time, then we cool it with some specific cooling rate. So when you are doing this heating, holding and cooling, your target is to improve the properties of the material. So you are doing all this to improve the properties of the material. But you know, whenever you are taking medicine, it is for the betterment of our body. But if you do overdose of that, it is going to affect badly. So my dear, when you take medicine, it is always to be taken as per the prescription. So when heat treatment is done, then we know up to which temperature we have to go, how we have to heat it, up to which temperature we need to hold it, and what should be the cooling rate. If all these things are not controlled, it is said to be uncontrolled heat treatment. And uncontrolled heat treatment are not going to give the better result. They are not improving the property actually. So because of that, when heat affected zone, we are going to see there we are not intentionally heating. So heat is going on because of welding. So sometime whatever the temperature they are rising, that is not in our control. Obviously, we don't know up to which temperature it is going to be heat and up to which time it would be heat. And we even don't know what would be the cooling rate. So everything is not in control of ours for that zone. So that is why uncontrolled heat treatment is going to happen. And when the things are going to be uncontrolled, definitely properties are going to be on the poor side. So that is why heat affected zone is said to be the weakest part. Very good, Deepak. So my dear, when we are talking about the unaffected zone, there no effect of heat, no alloy content. So it is having intermediate strength. So I will be saying weld bead is having the highest strength, then we will be having the unaffected zone, and then we will be having the heat affected zone. And I feel you are very well aware about one thing, that if the welding speed will increase, then my dear, the zone which is affected by the heat will also reduce. This question have already been asked in GATE examination, that when we are talking about the welding speed, if welding speed will increase, then my dear, heat affected zone will reduce. So there are many processes where we will see welding speed is very high. So because of that high welding speed, we would be having very low heat affected zone. Very good, Shubham. So guys, just like and share the session. I need more and more people to join it. And one more thing I would like to say, that you know, something is penetration, something is reinforcement. So we are going to define a term, dilution. Dilution is defined as the area of penetration to the area of weld bead. You can also write it as area of penetration, but a area of penetration plus area of reinforcement. And sometimes we are going to define percentage dilution as well. It is defined as AP by AP plus AR into 100. I also want to tell you one thing, that from this dilution type of term, you may also get numerical. So be ready for that. It would be a new type of numerical. Very good, Umar. Very good, Shubham. Very good, Deepak. So guys, now we are going to start the first type of welding, that is shielded metal arc welding process. So my dear, it is a type of arc welding. Okay. Yes. Very good, Shreyas, Umar, Shubham, Deepak, Manas, Surendra, Naveen, Sham, बहुत बढ़िया. So in short form, it is said to be SMAW. So sometime in GATE also they are using this short term. So you must be aware of that. So my dear, first of all, we will see about the principle of this welding process. So if you have this workpiece, two workpieces will be joined like this. This is the electrode. So what is going to happen whenever you are going to have this electrode and this workpiece? We are going to provide the power supply. Obviously, this is our choice whether we are using DC or AC. So there are different advantages, disadvantages for DC and AC. We will see them on the later stages. Okay. This is in our hand whether we want to take workpiece positive or electrode positive. For the timing, we are assuming workpiece to be positive, electrode to be negative. So obviously we are using this polarity, and let us assume this to be power source. For the timing, let us assume DC. On the later stages, we will see whether it is DC, where it is AC. So this is workpiece, this is electrode. So what is going to happen, my dear, between the electrode and workpiece, there is a air, there is a gap. Because of that, there is air. You know, air is not a very good conductor of heat, and very good conductor. Air is the insulator. So my dear, because of that, electrode and workpiece, between the gap, air is there. So resistance between them is very high. So my dear, obviously you are providing some potential difference with the help of power source. So my dear, this potential difference or power source what you are applying is generally having the potential difference between the range of 40 to 80 volt. I am giving you the general ranges. So whenever you are going to have electrode and workpiece, you are going to take electrode towards the workpiece. Then what will happen? When electrode will be going towards workpiece, the gap between them will reduce. And as the gap will be reducing, this potential difference will try to be enough to produce some kind of air ionization, oxygen ionization. So when this is going towards the workpiece, when this potential difference is enough to ionize the air between the gap, in that case what will happen? This is electrode and this is workpiece. Between this gap, whatever the air is present, that is going to start ionize. You would be having some positive charge ions and negatively charged electron. Positive charge ion and negatively charged electron. Positive charge ions and negatively charged electron. So air ionization will happen and environment will become ionized. So because of this ionized environment, my dear, in between this would be happening that electrons would be attracting towards the workpiece, because workpiece is positive and workpiece is positive, it would be attracting electrode and electrode would be attracting the ions. So my dear, electrons will be moving towards workpiece, ions will be moving towards electrode, and whatever this attraction is going on, because of that, obviously electrons have some kinetic energy, ions have some kinetic energy. Hi Ajay, how are you? So because of that, what is going to happen? Because of this, workpiece would be absorbing the kinetic energy of electron and electrode would be absorbing the kinetic energy of ions. And it have been seen that the kinetic energy of electron divided by kinetic energy of ions is found to be in the ratio of such that you would be having this to be 2/3 part and this to be 1/3 part. So if total 100 joule is there, 67 joules will be going to the workpiece, 33 joules would be going to the electrode. You already know workpiece is having thick plates. So it need more heat also if you want to melt them into good amount. So my dear, that is why when you are providing this positive electrode, I am not saying always electrode is negative. For this case I am talking about. So workpiece would be getting kinetic energy of electron, electrode would be getting kinetic energy of ions. And by getting that kinetic energy, it would be converting into heat. Because of that, first of all, this electrode wire is going to melt. Because this electrode wire is going to have the lowest melting point, and when it will start melting, after that, by taking the heat, this flux will also start melting. So flux is such that its melting point temperature is above than that of the electrode wire. Electrode wire and parent metal is of same material. So this and wire is of same material, flux is of different material. So my dear, flux is different material because it is going to provide the alloy content. Second thing, it should have high melting point temperature. Why it should be having high melting point temperature? Because if electrode wire is going to melt first, your melting will happen in such a way that electrode wire is melting before. So because of that, you will getting this type of shape, and the advantage of this type of shape is the flame, arc or spark, whatever you want to say, that would be concentrated towards the workpiece. And if by chance flux is going to melt first, then you will be having this type of diagram. If electrode wire is melting in the last, then your arc or spark will not be concentrated but diverged like that. In that case, it may not be able to do the welding. So for concentrated arc or spark, yes Malesh, good morning. For that convergent flame or convergent spark or arc, we want electrode wire shall melt first. So my dear, we have discussed actually two functions of this flux. Flux have a very first function that it would be providing the alloy content. Because of that, weld bead is going to be strongest, and that is why welded joints are said to have more stronger than the parent metal. Second function is, as it is melting in the last, that is why, because of which you are going to get the convergent flame, arc or spark. So my dear, when this will happen, now the mixture of electrode wire and flux will mix up and go inside the groove, and you will be getting the weld to be produced. So my dear, you will be having this weld pool, because when it is in liquid form, we will call it pool. After solidification, we will call it as weld bead. So my dear, it would be having the combination of flux as well as the molten wire material. So my dear, now what is going to happen? You know that flux material is having high melting point temperature, and also it have one more property, it is lighter than the pure metal. So as flux is lighter than the pure metal, when you would be having this molten weld pool, the flux material will be going up, because it is having lighter weight. Because of that, flux will be going at the top, and it would try to make a layer upward. When it will be making a layer upward, it is avoiding the contact of this molten metal with the air. You may be thinking, sir, why it is required to avoid the contact with the air of the metal? So my dear, metals have a bad habit, and that bad habit of metal is like we also have some bad habits. Some people are not able to control themselves by looking at the fast food. Some may not control on some other things. Likewise, metal cannot control when they see oxygen. They are going to immediately react with oxygen, and they will be making the metal oxides. So when they will be making metal oxides are found to be generally brittle, because they are of ceramic nature. So if they are brittle in nature, your entire weld will become brittle. Like, you know, whenever glass is going to be like, glass is a brittle material. When you are going to have a glass, and let us say by mistake, when you were holding it, it went down, it will break into parts. So likewise, if weld will be brittle, it will also break fast. But we don't want to have that property. We want that to be ductile in nature. So that is why we want that oxide shall not form. So this is the third function of the flux coating. So flux coating performs this function. It avoids air oxidation of metal. It gives us alloy content, and also gives the direction to the flame or arc or spark. So this is how the things are going to happen. So my dear, the entire setup is going to be like this. I would also like to tell you, in this zone, which is said to be, you can say, this is the zone where arc is going to be produced. There electrons and ions were moving. When electrons were going towards workpiece, ions were going towards electrode. During that motion, there was a collision between electron and ions also. So because of that collisions, we are going to have a very high temperature of around 6,000 to 12,000 degrees Celsius in between the arc gap. And my dear, in this arc gap, some ultraviolet rays are also going to be produced. So because of those rays to be produced, those rays are harmful for our eyes. That is why it is never advised, whenever you are going to do welding, arc welding, it is advised to have some glasses for that. So we need to wear the glasses for that. And that is why this type of glasses you have seen in the labs also, you were provided, and we were going to do welding with these glasses, because otherwise our eyes may be affected. If at some of the place arc welding is going on, you look at it for longer duration, you will feel some kind of you can say a pain in your eyes for next 2-3 days. You may not be able to sleep properly because of this. So that kind of effects are coming if you are not wearing the glasses. Okay, now my dear, the point is, sometime what is going to happen when these particles are moving up, this is that flux particle can make a layer over only if they are able to go up within time, because at the same time solidification will also start. So my dear, that solidification of this molten weld pool shall happen only once the flux particle go up and make the layer. Otherwise, flux particle will remain inside. So my dear, if flux particle are going to remain inside, then my dear, that actually after solidification, we are calling them slag. So after solidification, we are calling them slag. Slag is to avoid the air oxidation. If that slag is going to solidify in between the weld pool, it will make defect. That defect is said to be slag inclusion. So why this defect will happen? Because if that flux particle is unable to move up before solidification, which will be depending on the temperature of the weld pool, which will be depending upon the current settings, So my dear, if proper current is not provided, in that case definitely it is going to happen. You know the heat generation is going to be I square RT. So my dear, heat generation is directly proportional to I square. If current setting is not proper, heat generation will be not proper. In that case, you may not be having good temperature of weld pool, because of which slag inclusion kind of defect can appear. So my dear, we need to avoid this slag inclusion. For that, we need to work over the current setting. Now my dear, when we are talking about the current setting, you know definitely it would be a part of transformer. So my dear, when we are going to have the transformer, many types of transformers are coming. But first of all, you must be knowing one thing, that when this electrode is going towards workpiece, when this gap between them is reducing, lesser gap will require lesser voltage and more gap will require more voltage. So if I am going to make a diagram between voltage and arc length, it comes like this, a straight line. So we define voltage to be A plus BL. So if arc length will be more, voltage required to produce the spark will also be more. And guys, if that is the case, V is equals to A plus BL. So my dear, it means whenever we are having electrode towards workpiece, if that gap is going to vary, it will be definitely varying the voltage requirement. And if the voltage requirement will vary, definitely current will also vary, which will definitely result into slag inclusion, because if current settings are not proper, yes, uh, guys, am I audible and visible to all of you? Actually, I feel network issue happens. Fine, fine, fine. Okay. So we are once again starting from here. Don't worry. Okay. Yes. Fine, fine, fine. So guys, I would like to say that when we were talking about electrode and workpiece, okay, it is lagging. Let me once again do this. Yes. So guys, now is it fine? Now is it fine? I feel some network issue is there. Now I feel it is fine. Okay guys, now I feel it is fine. Now we are continuing. So as I said that when we are going to talk about this A plus BL curve we have just made, I was telling you about voltage. I was telling you about voltage with respect to arc length. So I told you that if the gap between electrode and workpiece, Just wait, guys. Sorry for the disturbances. Okay. Now I feel all the issues are resolved. Okay. Sorry for the inconvenience, guys. Now shall we continue? Shall we continue? Yes. Amir, don't worry. Actually, I have planned in such a way that both theory and numericals would be covered. Okay, both theory and numericals would be covered. Okay, so now we are going to continue once again. So as I said, let us say we have this workpiece and this electrode, and if the gap is more air, more voltage is required. If gap is less voltage is required. So we have seen that it is going to be a straight line. V is equals to A plus BL. This is the equation between voltage and arc length. Okay. So I said if you are doing this welding manually, you can see this is workpiece, this is electrode. So as the gap is changing, the voltage requirement will change. And if voltage requirement will change, my dear, then what will happen? Because of change of voltage requirement, obviously the current setting will also change. And if current setting is going to change, the heat generation will change. Because of that, the temperature will also change. So because of this, the chances of slag inclusion are there. So what we have seen, there are two types of movement between electrode and workpiece. One is movement of electrode towards the workpiece. Other is movement of electrode along the workpiece. So when we have two types of movement, this movement which is electrode towards the workpiece is very, very important, because based on that we are going to have the defect like slag inclusion. So that is why if both the movement we are doing manually, it is said to be manual metal arc welding process. If we are going to perform the critical movement with machine and non-critical movement manually, we will call it as semi-automatic type of welding. And if we are going to perform both the motion with the help of machine, it is said to be automatic welding. So based on that, we have three types of welding. So towards the workpiece, along the workpiece, this is the critical movement, because if this is not proper, slag inclusion will happen. This is non-critical movement. Okay, this is non-critical movement. So based on these, we have three types of welding process. If both are going to be done with the machine, if both are going to be done manually, then it is manual metal automatic, and the best solution is semi-automatic, where critical movement would be done with the machine, non-critical movement will be done manually. So my dear, now if we are going to perform manual metal arc welding process, then in case of manual, it is damn sure that arc length will change. Because of arc length, voltage requirement will change. Because of this, current is going to change. So we wanted some temporary solution also for that, because under some situation we may not be able to go always for the automatic types of welding, where maybe we want to save. Is there any issue with audio now? Are you facing any audio issues? Are you facing any audio issues? I feel now everything is fine from my side. Yes. So my dear, if that kind of thing is going to happen, we wanted some solution for this. So we thought let us make a transformer which will be providing us less change of current for more change of voltage. So that transformer was given the name of Drooper. So Drooper is generally preferred with the manual metal arc welding process when we are going to have the movement between this electrode and workpiece which is done manually. So for such cases, we are going to have this type of characteristic which Drupal is going to provide. So Drupal provide this type of characteristic. So if you see, we are going to have this voltage related to that current will be this. So I am saying this is V1, this is I1. If voltage is this much, current is this much. So you can see, my dear, when voltage changes from this to this value, current is changing very less. So in the Drupal, the change of current with respect to change of voltage is very, very less. So my dear, if that kind of thing is going to happen, we can use it with the manual metal arc welding process and the chances of slag inclusion would be reduced. But my dear, if we are going to have semi-automatic type of welding, for that case, we need not to go for Drupal. For that case, we are using this type of voltage arc length characteristic where we are defining it like previous one is said to be constant current transformer. Constant current transformer. Okay. And similarly, this one is said to be constant voltage transformer. Constant voltage transformer. But my dear, if I am going to show some linear voltage current characteristic, if I am going to show some linear voltage current characteristic, there I can make the equation of this type of transformer. Like you have seen, it was linear. So if I plot it like this, then this voltage is said to be open circuit voltage and this current is said to be short circuit current. So my dear, I already told you, if we have a circuit like this, okay, like this, and we are going to have, this is going to be the battery, let us say, okay, we are going to have a battery like this. We are going to show this. So when we are going to have this circuit, this is said to be open because there is nothing in between. So in this circuit, whatever the voltage you will be having across these two terminals, that is said to be open circuit voltage, or this is something you are calling it as EMF, electromotive force. So you would be knowing that in the 12th class you were writing an equation that voltage can be written as EMF minus I times of internal resistance. That internal resistance is defined as EMF divided by short circuit current. So open circuit voltage is that maximum voltage when no current is flowing in the circuit because it is open. And short circuit current is that maximum value of current when there is no, when you will be having zero potential difference, means there was a time when this electrode was stick to the workpiece. At that time no spark was getting produced because the circuit was complete and direct flow of current was happening. That condition is said to be short circuit. Their welding was not happening. So at this current, welding will not happen. At this voltage also welding will not happen. But from this straight line, if you want to write the equation, you know, we can write x by a plus y by b is equals to 1. So you can write x is having I. So I by is plus v by v naught is equals to 1. Whether you use this or you use this, you will be getting a wonderful equation of transformer, and that equation is given as v is equals to v naught minus, this is going to be I times of r we have written. So it is v naught minus v naught by is into I. So we can also write it as open circuit voltage minus open circuit voltage by short circuit current into I. This is the equation of the transformer, and from this a lot of numericals are coming. A lot of numericals are coming. As this session is related to the marathon, I am going to take majorly theory here only. Okay. Bilkul Chili Mishra. That's what, for what only we are going to do this hard work. Okay. Yes, very good guys. So I have given you this equation, and soon we will be having the practice session where we will solve some problems onto this. Now my dear, there were some problem with the manual metal arc welding process, because of which we are going to the second type of arc welding, that is submerged arc welding. You have seen, if that manual metal arc welding manually, the first issue which was occurring at that time was the problem with this motion. Yes, if we were using dropper, the problem was resolved, but still that was a temporary solution. So if this motion to be perfect, we are going to include machine for that. So submerged arc welding process is a semi-automatic type of welding. This is a semi-automatic type of welding. This is the first improvement we are getting. Okay. Hello Teju. So the first improvement we are getting is submerged arc welding is a semi-automatic type of welding. Then my dear, we were also having some other issues. Like my dear, what was going to happen? Previously we were using some electrode wire. Which was having some flux material. So it was having some kind of flux material. So because of this flux material, you were having this electrode wire and it was having some size like 9 inches, 1 feet. So once one electrode wire is going to melt out, you need to change the electrode. So once you are going to change the electrode, for that you need to stop the welding process. And if we need to stop this welding process, it will become a discontinuous process. So my dear, if we want to join two plates like that, so after some time, like this electrode is enough, we will be have a joint. Then this electrode enough, we will be having a joint. So in that kind of process, we will be having a number of joints present between that welding. So if the joints are present at the joint, there are chances of leakages. So if we are going to weld the LPG cylinder or ship, in that case, if that kind of joint will happen from where leakage will happen, so in case of LPG cylinder shipbuilding type of application, we may get some kind of accidents. So to avoid that, we needed the continuous welding process. So this process is going to be a continuous welding process. So to make the process continuous, we have replaced the electrode with the electrode wire. So this time we are going to use this electrode wire, which is going to move continuously because it is present in the wire spool. So continuously electrode wire will be coming. And my dear, for that continuous input, we are also going to provide the servo mechanism. In this servo mechanism, two rollers are there, which are going to send the electrode wire at a constant rate. Because when it is going to be at constant rate, the problem of this movement, this gap will also be resolved. Because of this constant rate, my dear, you would not be having slag inclusion kind of defect. It is becoming semi-automatic type of welding. But my dear, if you are providing wire in this format, if flux is also there onto the wire, that flux may get eroded from the wire because of friction when it is coming again and again between the rollers. So to avoid that, we are not providing flux onto the wire this time. Flux is provided in the flux drum in the molten format. Okay, so molten flux is separately provided, which would be making a layer outside and performing its function very nicely. It will perform all the function. It will avoid the air oxidation because air is not coming in contact, and this flame or spark is going to be concentrated because once again the convex type of shape is there. So all the functions are going to be performed in the same way. This process can be used for two wonderful applications like LPG cylinder, and also the second application we have said is what after LPG cylinder, that is the shipbuilding. So my dear, as you know, this is a continuous process. It can be used for mass production, and as here high speed of welding is possible. So whenever welding is going to be with high speed, the chances of heat affected zone will be lesser. So heat affected zone is going to be smaller for such case. Yes, please tell me guys. Teju, Amir, Shili, Shreyas, Sri Arvind and other students, please tell me up to this everybody got it or not. So I have revised this. These are the application. In short form, submerged arc welding is also said to be SAW. Ramesh Mon, hi dear, how are you? Sir, shipbuilding, yes, Amir, that is correct, that I will be telling you. But if you are not having the option of electro-slag or electro-gas welding, for such case, you can tick this submerged arc welding also. Okay. So otherwise, submerged arc welding is preferred for LPG, and for shipbuilding, we are preferring electro-slag. But if electro-slag is not in the option, we can go for submerged arc welding. And mass production is possible because of continuity of the process. Moving further, guys. So my guys, these are the points we have already discussed. So my dear, as continuously welding process is happening and molten weld pool is protected under the environment of what? The flux, molten flux. So guys, here chances of spatter are less. Why? Because my dear, that electrode wire is continuously within the environment of molten flux. So there is no contact of air, and this flame or this arc cannot be deviated. If it would be deviated, it can also create some kind of molten droplets on the metal surface, which is scattering of molten metal, which is not going on here because there is no contact of air with the flame or spark. So my dear, less chances of spatter is there. Spatter is a defect which is known as scattering of molten metal. So that is also having less tendency here. So guys, this is scattering of molten metal have less tendency here. So the defect of spatter will not be there. The defect of slag inclusion will also not be there. So now we are moving to the third type of welding process, that is TIG, MIG arc welding process. Generally, you know, TIG is said to be tungsten inert gas arc welding. Tungsten inert gas arc welding. Then you also know that MIG is metal inert gas arc welding. Generally, students are getting confused over this because the name is tungsten inert gas. They are not using arc word. They feel it is tungsten inert gas welding. So it is not a gas welding technique. It is an arc welding technique. So the name is TIG arc welding or MIG arc welding. This is the name of this welding process. So my dear, when we are using the tungsten electrode, we call it as tungsten inert gas arc welding. So my dear, when you will be using tungsten electrode, let us say this is the tungsten electrode. So tungsten electrode is going to be non-consumable electrode. It is not going to melt. So my dear, because of that, we are not going to provide any flux over it. And my dear, at the same time, when you will be using this electrode, as it is not consumed, so molten metal will not be coming from this tungsten. So for that purpose, we are going to use some filler rod in this type of process. So that filler rod is made up of the same material as that of the parent metal. So they have same material. So we will be using this consumable rod separately. So my dear, what is the purpose of using such type of thing? Why we are using the tungsten? Tungsten is very, very hard and brittle material. So that is why if by chance its droplet will come inside the weld pool, it will make entire weld brittle. So we never want that kind of thing. First thing is very, very clear from here. Second thing is, my dear, when we are using this tungsten, what is the reason behind that? Till now we were using the polarity with workpiece was going to be positive and electrode was going to be negative. But my dear, this was fine, and this type of polarity is said to be the straight polarity. But my dear, when we are going to have aluminium type of material, it is very, very difficult to weld the aluminium. So weldability for aluminium is very, very poor. So my dear, why it is? You already know metals cannot control themselves when they see oxygen in the heated state. But aluminium is that much reactive that even at room temperature it reacts with oxygen and make a layer of aluminium oxide, Al2O3. So this Al2O3 is a kind of ceramic material which is very, very hard and brittle. We cannot weld it. So for welding of aluminium, we need to remove this layer. So for that purpose, we are going to reverse the polarity. And when we are going to reverse the polarity, this time workpiece is going to be negative and electrode is going to be positive. What is the benefit of that? When workpiece is going to be negative polarity, now during the welding process, electrons will be coming out from the surface of aluminium. So when electrons will be coming out from the aluminium surface, they will just peel off the layer of aluminium oxide. So when they will be peeling off the layer of aluminium oxide, that layer will be removed and fresh aluminium will be exposed for the welding purpose. Do we get alloy composition in weld? Dear, if you want alloy composition, you would be providing separate powder for that purpose. But actually TIG welding is generally done for aluminium, very thin plate of 5 to 8 mm. So for that we need not to do all these kind of thing. So my dear, when these electrons are going to go out and peeling off this layer, that process is said to be cathodic cleaning, like Manas have written. So you might be asking, sir, what is cathodic cleaning? So my dear, cathodic cleaning means we are going to make the workpiece cathode, means negative, and then we are cleaning it. So that cleaning is happening because of this cathode. So that is why the name is cathodic cleaning. But now the problem is you are making electrode positive. So for that, the melting temperature of workpiece electrode should be very high. So we are using tungsten or tungsten carbide, because melting point temperature is more than 3500 for such cases. So my dear, no doubt, if by chance even a single droplet of tungsten will be going into the pool, weld will be very poor. So we need to avoid that. So we never make this type of electrode. In reality, when we make the tungsten electrode, we make it of this shape. Means if here the diameter of this tungsten electrode is D, we will be keeping the diameter of the surface to be 1.2 to 1.5 times. Means 20 to 50% more diameter we are going to keep. So my dear, when we are doing this, now the heat required to melt the tungsten electrode would be more. So because of that, the chances of melting will get reduced. And my dear, this thing is said to be electrode preparation. And my dear, whenever you are doing here welding, we can weld very thin plates of aluminium, because workpiece is getting less heat, because negative was getting 1/3 part of heat, positive was getting 2/3 part of heat. So that is a kind of limitation for this process also. So my dear, when we are using this TIG, here we get to know about the term weldability. If we are going to talk about the weldability of steel, I would like to say that weldability is inversely proportional to the carbon content. If carbon content is going to be more, weldability will be poor. So that is why whenever we are going to have low carbon steel, medium carbon steel and high carbon steel, so weldability is going to be poor for high carbon steel, then highest for low carbon steel. Weldability is directly proportional to 1 by carbon percentage, or I will say weldability is inversely proportional to the percentage of carbon content. Okay. So my dear, now the point is, here you are not using the flux. Who will solve the purpose of flux? We are not providing here molten flux. We are providing the inert gas. So this inert gas will be solve the purpose of flux. Inert gas will be solving the purpose of flux. So inert gas will be solving the purpose of flux. Okay. So when inert gas is provided, inert gas will also helping us to make a flame which is going to be concentrated, because from throughout the sides we are going to provide the inert gas. It will also avoid the contact of air, and inert gas is non-reactive, so there would be no reaction between the surface with the inert gas. That is one more advantage. So inert gases, you can use helium, you can use neon, you can use argon. Generally we are using argon for availability point of view. So my dear, we have studied TIG process. Here there are some problems. One is you are using tungsten electrode which is non-consumable. Still chances of consumption is there if temperature increases beyond a range. Second problem is we are using this non-consumable, so filler rod is required. Filler rod will be having a constant size. Once again you need to stop the welding, and because of this you can say negative polarity, reverse polarity, you cannot weld the thick plates. So for that purpose an improvement come in the form of MIG process. In MIG process we have replaced the tungsten electrode from the metal electrode which was consumable, so filler rod is not required. Here we were once again providing the servo mechanism. So my dear, continuous flow of electrode will be there. Once again you are using the inert gas for the purpose of flux. That is why the name is metal inert gas arc welding. And my dear, when we are going to do this, we have removed, this is inert gas in general. Inert gas is going to be very costly. if you're going to replace this inert gas by CO2, which can be done with the metal inert gas welding, then this CO2 is not an inert gas. So the name of the process will become active gas metal arc welding process. So my dear, this is the process nowadays used in the industries. It is similar to submerged arc welding. Okay, so this process is active gas metal arc welding, and this is used in industry. It have replaced TIG process. Okay, I feel everybody is getting this. Okay, everybody is getting this. So this is said to be the MIG process. So my dear, now I am going to tell you something more about numericals. There are three types of heat. One is heat generated, which is given as I square RT. Second is heat supplied. Okay. Third one is heat required. So my dear, let us say we need some 700 joules of heat for welding or melting purpose. Then my dear, for melting purpose, if we require this, we may be providing some 1400 joules. So why we are providing more? Because during welding, that entire setup is exposed to atmosphere. So there would be some losses of heat to the atmosphere. Okay. So as some losses of heat are there to the atmosphere, because of that we are providing extra heat. So my dear, if requirement is 700, you are supplying 1400. So this gap of 700, this is going to be the heat loss to the surroundings. Okay. Then my dear, whenever we are going to have this heat supply, for that we need to generate the heat. Heat generation takes place by this formula, and let us say we are going to generate the heat of 2000 joules. Why heat generation is more than supply? Because heat is generated at the tip of electrodes, then that heat is distributed, then also some kind of heat loss to surrounding happen. So here also there would be a heat loss, that is of 2000 minus 1400, 600 joules, and that is said to be heat loss 1. This is heat loss 2. So guys, this total is the heat loss to the surrounding. So heat generation is 2000, requirement was 700. So my dear, based on these three types of heat, we are having three types of efficiencies. First is the efficiency of heat transfer, which is defined as heat supply by heat generated. It can also be written as rate of heat supply by rate of heat generation. Then thermal efficiency, okay, or we can also call it as melting efficiency. This is heat required but a heat supply, or we can have rate of heat required but a rate of heat supply. Then we are going to have overall efficiency, which is written as efficiency of heat transfer into melting efficiency. If you are going to define it, it is the rate of heat supply but a heat generated into heat required but a heat supply. So you would be having supply cancel, heat required by heat generated. So guys, you may be thinking sir is going very fast, but as I already said that this is the revision marathon. So here it should be like when you are reading your notes, so you must feel like from the notes like you have seen in the movies, whenever letters were exchanged, from the letter always the actress was looking like and he was feeling actor is speaking. So this marathon is of that type only, like your notes are speaking. Okay. Their process is welding. So generally process efficiency will be said to be this melting efficiency only. But in general they mention in these terminology which we have discussed here. Okay, I feel you got it. Okay. Ha, Chili Mishra, don't worry. So dear, numerical kisi ke bhi ho, whatever formula we are discussing, they are going to be useful only. And I am planning a practice session of welding and casting both on Tuesday. So there you will see all the types of questions. So don't worry about questions also. Here you revise. Tuesday we will do the questions. Now you can see this is direct current straight polarity, direct current reverse polarity, and alternating current. So this table is very important for exam. Sometime 1 mark question is coming from this. Okay. So guys, just like and share the session, because still we have completed only one type of welding. But you know, after resistance welding, the time required would be less. If you see in the classes, we have covered whatever we have covered in the 4 hours, that we have covered in this 1 hour. because 10 to 15 minutes problems were also there in between. Now my dear, we are talking about the polarity. So in direct current straight polarity, we are going to have workpiece positive, electrode negative. We are going to have workpiece negative, electrode positive. Direct current straight, direct current reverse. Here workpiece will be positive, negative alternately, electrode would be negative, positive alternately. Heat generation. Here workpiece would be having 67%, electrode would be having 33%. Here workpiece would be having 33%, electrode would be having 67%. Here both workpiece and electrode would be having 50-50%. Okay. Then penetration. So here workpiece is getting more heat, so we would be having deep penetration. Here we will be having shallow penetration. Here we will be having intermediate penetration. Wire feed rate means with what rate electrode wire is melting. That would be less here because less heat on electrode, more here and more heat of electrode. Here it would be intermediate because 50-50 heat is there. Thickness of plate you can weld here. In straight polarity you can weld thick plates because workpiece getting more heat. Here thin plates because electrode getting less heat. Here intermediate because both get 50-50. So workpiece, here I would like to say workpiece preparation. We have already seen electrode preparation. So if my workpiece size is less than 5 mm, then we are going to directly weld them. For more than 5 mm, we are going to provide some kind of preparation for more molten metal to come inside. This thing is said to be the workpiece preparation. So workpiece preparation is done when plates are of more thickness. So my dear, workpiece preparation is done in the DCSP. Do not done here. Here we will say it depends what is the thickness. So if thickness is generally more than 6 to 8 mm, then only we are going for this workpiece preparation kind of thing. Different book shows different value for that. So moving further guys. Okay, now numericals we are not going to do here. So I am having these numericals, but that we are not going to solve. Now we are moving to plasma arc welding. For numerical we have session on Tuesday where we will take casting, welding, forming all. Plasma arc welding. This is one more type of arc welding. You must be aware of plasma. So my dear, plasma is the fourth state of matter. Okay. Plasma, when we are talking about, is nothing but ionized gases. So ionized gases is said to be the plasma. So my dear, generally we are going to use the nitrogen gas. Okay. So here what we are going to put, everything is same. We would be having a tungsten electrode like that. Then we would be having some plasma gases like nitrogen. Okay. We would be having plasma gases like nitrogen. Then my dear, we are also having the inert gas to perform the function of flux, that is let us say argon. Okay, we are having this workpiece. Now as this is tungsten electrode which is not going to melt, we have to use some filler rod also. So my dear, in this process I would like to tell you, when you are using this plasma, you can get a temperature from 8000 degrees Celsius to 50,000 degrees Celsius. That temperature can be produced, but for welding we are restricting it to 20,000 degrees Celsius. You may be thinking, sir, at that temperature plates will get melt out. So I am not saying that temperature will be there with the plates. That temperature would be there with the gases. So whenever these plasma gases are going to react with the arc, because you are going to provide here some power supply. So whenever these plasma gases are going to react with the arc, they will convert into ionized gases. Ionized gases are said to be, these plasma will get a very, very high temperature. Like whenever you are sitting in front of fire, you are going to see that that fire is definitely having some very high temperature. But when the air taking the heat from that will be coming to us, then when it will be giving heat to us, that heat will not be creating that temperature for our body. Okay, why? Because our area is more, so when that heat would be distributed, our temperature will not reach to that much. So that is going to happen when those plasma gases are going to come to this workpiece. A deep and deep penetration will be there, and that is why when this kind of welding going to take place, we will call it as keyhole phenomena. Why keyhole phenomena? because when this plasma will be giving energy to the plate, then my dear, it is going to get cool off. So because of that, you will be getting the keyhole type of weld bead here. This type of weld bead you will see, because when the plasma will be attacking, that would be giving energy and it would be reaching to the deep, but with the very less thickness. So this type of weld bead you will be getting here. सर वेल्डिंग के कंपैरिजन में भी आता है, तो वो पैरामीटर को सर कंपेयर करने में दिक्कत होती है. Okay dear, for that I will provide you the actually you are asking about the temperature. They are asking which welding process is having highest temperature. Okay, so that kind of I will provide you a table where it would be mentioned the temperature ranges of different welding processes. So that table will solve your purpose. Okay, you might be thinking, sir, when we are restricting the temperature up to this, where we use this temperature? When you would be going for plasma arc cutting. So in the metal cutting, plasma arc cutting will be there. So there we will be using more temperatures. So here we are restricting our process to this. And my dear, all other things are going to be same. Here we need to cool the electrode also, otherwise electrode may get that high temperature and melt out. So for that purpose, sometime we are going to provide some artificial cooling. Okay, so water cooled nozzle are going to be provided all around the tungsten electrode to keep it cool for that welding process. Okay, so that is said to be plasma arc welding process. Now the last type of arc welding process is electro gas or electro slag welding. Okay, so my dear, in this what we are going to have, I am showing you with the simple diagram. You are going to have this as workpiece 1, this as workpiece 2. You can consider them to be the two plates of the ship, and you want to join these two plates edgewise. So when you want to join them along the edges, you need to pass your electrode wire from here, so that this electrode wire can provide molten metal here. For that, my dear, to start the welding, we need some starting point, otherwise molten metal will spill away. So my dear, for such type of welding process, we need to provide a starting plate for the welding. So we would be providing a starting plate. This is the starting plate. So initially, the arc is going to be produced between this starting plate and the workpiece. And my dear, we would be providing the power supply like this. And once the welding is going to start, this electrode wire after melting will be going up and weld will be moving ahead in the upward direction. For that purpose, you know that if molten metal is not going to be solidified soon, then it will still spill away from the sideways. Okay, you have provided starting plate, but from the sideway it can still spill away. So for that purpose, we are going to provide some copper shoes. The copper shoes are like this. Okay, so in between electrode wire is there. This is copper shoes. When the melting takes place, copper shoes will take the heat and solidify the molten metal and move in the upward direction. So my dear, when this kind of thing is going to happen, this will be moving in upward direction. So here you can see these are the copper cooling shoes. So they would be, these copper cooling shoes are there. So this will be moving in upward direction with the welding process. This is the starting plate which is required initially. Okay, so as the solidification will take place, this will move ahead. So here also flux is not there. So for flux, we are going to provide the molten flux. So molten flux is provided in between. My dear, here actually the loss of heat from the sideways or all around is not going that much. So because of that, my dear, what is going to happen? Because of that, sometimes the heat is going to be very, very high. So for such cases, we can switch off the arc for such some time. Because of that very high temperature, welding will continue without any arc or spark. So you can switch off the current and welding will still take place. So when you are switching off this for some time, the temperature will go down. And once again, when the temperature go down beyond a value, you will once again switch on the arc. Okay, is it clear? Thanks, Amin, for your wonderful words. So this is what is going on for electro-slag and electro-gas welding. And my dear, this is one type of arc welding only. when we call it electro-slag and when we call it electro-gas. When we are going to use the molten flux, we call it as electro-slag. And when we are going to use the CO2, we will call it as electro-gas welding. Guys, on my Telegram channel, we are also having some handwritten notes of this welding. So whatever I am saying, word to word is written there. So after learning the process, you just need to remember only the application of the processes, nothing more than that. And you need to practice the numerical. So those notes now will, if you go through this, that will be very easy for you to understand. Okay, those who are learning for the first time, those who have already learned, for them already this is the revision. So guys, electro-slag and electro-gas welding is a vertical welding process. So it is used for what? It is used for what? For shipbuilding. We have already seen previous process was good for LPG cylinder, and this is good for shipbuilding. With this we have completed the arc welding process. Now my dear, we are moving to the other processes because arc welding is over. You can see every theory is also written in the slides. Okay, so my dear, now we will move to the other processes. Okay, so moving to resistance welding. So whatever I have told, all theory is also written in the slides. Okay, very good Shruth, very good Naveen, wonderful. Amir notes and this lecture. Yes, Amir. That was the exact word that I wanted to tell at that time. That if you have that notes, then this class is the audio book for that. Okay. So these days there is a trend of audio books. So you can get that advantage. Moving to the second welding process, that is the resistance welding. So my dear, in the arc welding, voltage was playing a very, very important role actually. Okay. So if we are talking about the arc welding process, that is said to be high voltage and low current welding process. But when we are talking about the resistance welding, it is low voltage and high current welding process. When we are saying this, many students are getting confused because they see in the question voltage is given in the range of 40 to 80 volts and current is generally, they have seen that from 400 amperes to 1000, 1200, 1300 ampere. Likewise, this is written. So they say, sir, current is more than voltage. So guys, comparison can never be done like voltage with the current. Comparison is done with the voltage, current with the current. So here voltage may be up to 12 volt. So 12 volt and 40 to 80 volt, this is more. And here the current, if you are talking about, it is more than 10,000 amperes. So just compare this current and this compare. So here current is more, here voltage is more. So in the resistance welding, current is more than 10,000 ampere. In general, even sometime you will see the value of 1 lakh amperes, 50,000 amperes, 35,000 ampere. So here as the current is very, very high, all of you are aware that heat generation is written as I square RT. So as current ka square is there. So if current is very high, you need to reduce this time because you cannot have that high current for more time. Otherwise, the entire plates will melt out. So Sagrika up to lack of very good Sagrika. So my dear, if you see the types of resistance weldings, so first of all, why we need it? So my dear, till now we were doing the arc welding, and arc welding were performed in the form of butt welds. Okay, like this plate and this plate are kept like that, and you are welding it in the butt weld configuration. We have not seen any process where we were doing lap joint configuration. So resistance welding came for the purpose of lap joint configuration. When for the first time you are going for this lap joint configuration, the name of process is resistance welding. So the types of resistance welding is spot welding, projection welding, flash butt welding, high frequency resistance and induction welding, and seam welding. All these are the type of resistance welding. And after this welding process, other welding process will not take that much time. As I said, we are going to complete in 2.5 hours. So this is the first type of resistance welding process, spot welding. So my dear, what is going to happen? This is workpiece 1, workpiece 2. This time you are going to keep 2 workpieces like this, and I would like to tell you there is a lower die which is fixed. Upper die is movable. So my dear, this is the upper die, or I shall not say it die. It is actually the copper electrode. So these copper electrode, generally this is said to be the fixed one and this is said to be the moving one in general. Okay. So when we are going to apply the force from that, some penetration will happen from both the sides because pressure is applied from both the sides. So this much penetration will happen, electrode will get penetrated into the sheet. Now my dear, this phase is said to be the penetration, and in this phase, if I show you two diagrams, one for the pressure, other for the current. So this first time is said to be the squeeze time. For that time we are going to increase the pressure and there is no current flowing for that phase. Okay. Now my dear, what will happen after that? After that my dear, this squeezing time is over. We are going to supply some current. That very high current is going to pass like this. So my dear, when this current is passing, obviously every surface will show some resistance. There is resistance of this copper electrode is R1, R1. Then there is an resistance of this surface, interface between copper electrode and workpiece 1. So this resistance I will be giving the name of R4, R4. So here also R4 will be there. Then my dear, there is some resistance provided by this mild steel plate. This I am showing it by R3, R3. And my dear, there is a resistance between the interface of two plates which is denoted by R2. So you can see R2 is 1 time, R3 2 times, R4 2 times, R1 2 times. So if you see this R2 is quite more than all other resistances which are already 2 times to R1 plus R3 plus R4. Summation of that is even lesser than this R2. So R2 resistance is very high, and because of that high resistance, when the current will get passed, here we will be having more generation of heat, and because of that more resistance, more heat, here my dear, weld is getting produced. And when the melting will start from the center, this weld bead, this zone, fusion zone will start expanding. This may expand in the shape of sphere, in the shape of cylinder, in the shape of any other geometry. But here we have shown like a cylinder, but this can be cylinder, can be ellipse, can be other shape. But in general, we will assume it either a cylinder or a sphere. So as per our assumption, it would be cylinder or sphere for easy calculation. Otherwise, it can take any shape, and this fusion zone will be reaching up to the electrode and we will get this weld to be done. Okay. So this is how the welding will be performed. So my dear, if that is the case, this is the second time, like already in the comment section we have, this pressure remains same, and for this time we are going to provide some current. So my dear, this time is said to be weld time. Now because of this melting, obviously between this melt is going to take place, but this time we will not call it as weld bead. This time we are going to call it as weld nugget after solidification. So my dear, until this gets solidified, we will maintain the pressure but no current will be supplied. So for this time pressure remains same, current is 0. This is said to be the which time? Hold time. After that we will relieve the pressure, and as the pressure is relieved, this weld is performed. You would be getting these two plates to be joined with the joint, and as the joint is like a spot, we will call this process to be a spot welding. So this is how the process is going to be over. Yes. Yes, very good. Very good, Sagrika. That's really great. Thanks for that. And even you can get my handwritten notes from the Telegram channel. So that will also further help you. Okay, Sagrika. So let us move further. Very good. So this is the spot welding process. So this is the squeeze time. Then we are going to have weld time. Then we are going to have hold time. Then we have relief time. So this is what is going to happen. So my dear, these are the resistances defined like that. So these are the curves we have already seen. So my dear, when we are talking about these resistance welding, I would also like to tell you that when we are going to have this, the heat generation, we are going to have as I square RT. This is the heat generation going to take place. So my dear, if you are going to see that whatever the heat required for melting, that would be like mCp delta T in general. Okay, this is required for increasing the temperature to melting point temperature. Then we would be requiring m into latent heat. Okay, so that would be required for the melting purpose. So these are the two heats generally required. This is said to be sensible heating. This is said to be then latent heat. So with that, the melting is going to take place. Generally, that is the heat required. So my dear, if you are going to say this heat required, you must also understand that if we have some thickness, if thickness is going to be more, then my dear, heat generation required is also going to be more, because more thickness will require more heat to get melt out. Okay, so my dear, if that is the case, we can also say that thickness is directly proportional to heat generation, which is I square RT. So it is directly proportional to I square, and this thickness is also directly proportional to the melting point of the plate. Sorry, I am going to correct it, don't worry. I would like to say that this this I square is also directly proportional to this melting point. If melting point is going to be more, then also the current requirement will be more. So my dear, why I am telling you these things? Sometimes the questions are coming that for this much thickness, this much current is required. So for that much thickness, how much current would be required? So if they say for TH1 we need I1, for TH2 what would be the current requirement? So you can say that thickness is directly proportional to current ka square. So TH1 by TH2 can be written as, this is I square is there. So it can be written as, this is I1 ka square by I2 ka square. Similarly, if thickness are not given, melting point are given, then you can write melting point of 1 by melting point of 2 is equals to I1 square by I2 square. Okay, so in the using those relation, you can find out the unknown if any unknown is there. So from these formula till now there is no question asked. So because of that, in the practice session, I will take these type of question. So you all must attend that practice session. There I would be taking all these things. Okay. Now we are talking about the projection welding, the second type of resistance welding process. This is more theoretical. If you see, my dear, when we are looking for more number of spots, like if we are joining the two plates in such a way that we require spots at multiple points. So for that purpose, we are using projection welding. So the second name of projection welding is nothing but multi-spot welding. So my dear, if you want spot at multiple places, we will call it as multi-spot welding. Here, my dear, we will be having one plate on which the projections are going to be given, and the projections are provided like this. The places where you need the spot, we provide the projection. These projections are made by a process known as embossing, which we are going to study at the time of metal forming. Embossing and coining are the similar processes you must have seen there. So embossing is the process which is going to be used for this. And my dear, what we are going to do, once again, similarly, we would be having the copper electrode on both the sides. So this time, once again, when you will do the squeezing, then my dear, at these projections what you have made, those projections are going to be broken. Because of that, because of why these are broken, they are going to be broken because you are applying the pressure. So some plastic deformation will happen. So these projection would be broken. So obviously wherever the projections are there, the sheet which is having the projection, that will be having more heat because of this plastic deformation. So generally projections are provided on the sheet which have either good conductivity or have more thickness, so that it can bear that kind of heat and transfer it to the surrounding. So my dear, whenever you are using this process, all other things are going to be same. Projections are going to be there only at the places where you are providing the projection. So only that places will provide you the spots of the welding. Okay. So when we are using this, as it is continuous welds, continuous spots you are getting. So my dear, in general, spot welding is going to be used in the automobile sectors. And when you are going to make so much spots together, then also the chances of leakages will be there, because it is not a continuous type of welding. Okay, so my dear, when we are having this projections, it is like that. So these are the hot spot, because whenever you would be providing them, plastic deformation will happen there. And if you are going to compare these two plates, if they have different thicknesses, then this would be having more thickness and this would be having less thickness. If they have same thickness, conductivity is different, then this sheet will be having more conductivity, this will be having less conductivity. These are the point you need to take care in this type of welding process. Okay, dear, projection welding ke projection chili mishra, when we are going to make these projections, then these projections are made by embossing process. Embossing is the metal forming process. Like when you will be making these projection in the sheet, you would be putting this sheet normally at some place where you would be using this type of die. You would be having a die of this type. So when you would be having die of this type, when you will apply the pressure, this sheet will be converting into this sheet where projections are there. So these projections are made by this kind of process, and this process is said to be the embossing. We will be having more clarity on embossing and coining when we will see the metal forming chapter, means tomorrow or day after tomorrow we will see that. Okay, now we are moving to the third type of resistance welding process, which is the flash butt welding process. My dear, as we have already seen that this welding process came for the lap joint configuration. So when this came for the lap joint configuration, some people think that we cannot use it for the butt joint configuration. So it is not like that. We can also make the butt joint from this type of welding. For that, what we are going to do? We are going to place two rods which are going to be joined together. Now, my dear, this process is generally used for joining the railway tracks in the developed countries. Okay, so railway tracks are joined by this process in the developed countries like America and all. In developing countries, we use thermite welding for the purpose. So you would be keeping two railway tracks together like that, and you would be taking them towards each other. When they will be going towards each other, there would be a time when they will just connect with each other. So my dear, you are going to provide this pressure. At that time, we are going to provide some current here as well. And my dear, that current is generally of the range of 1 lakh ampere. So my dear, initially, as you know, some oxide layer may be present on the metal surfaces. So some flash is going to generate it. Initially, that indicates the burning of oxide layer. That is why the name is flash butt welding. Then after that, because of this high current and this pressure, the weld is going to take place. In arc welding, we were only using the heat for the welding process, whereas in resistance welding, we are using heat as well as pressure both for the welding process. So I feel you are getting it. So this is flash butt welding process. The important point here is 10 to the power 5 ampere of the current. Okay. Moving to the next, that is seam welding. This is not projection but the seam welding. In the seam welding, you would be having two plates like this. These are two plates and you are providing some roller. So for this roller, they are also provided the power supply like this. So whenever these rollers are moving continuously over the surface, they are continuously providing some penetration. Okay, so some continuous penetration is there. And here current is also passing, and as you know, at the joint of the sheet, at the interface of the sheet, we would be having the highest resistance. So because of highest heat there, weld will take place. This is the process which is continuous welding process. So my dear, if you see the spot welding, if you see the projection welding, they were discontinuous welding processes. But this is going to be the continuous welding process. Sir, sometimes in numerical they are using 6D, yes, root T, and other times D is equals to T. What should we use? Dear, it depends on the thickness of the sheet. When thickness is coming out to be less than 8 mm, then we are going to use this, what you have mentioned as D is equals to 6 root T. Okay. So my dear, that is actually coming from the data book. In the GATE question, you will not get that kind of thing because that requires data book. So from the data book only, when thickness is less than 8 mm, then we are using this relation what you have mentioned. Okay. So I also taught at that time of welding when I was teaching you. And my dear, in this process, as continuously current is flowing, so at this point when roller reach this place, this much part is already welding. So sometime it happens that when you are reaching to the new position, some part of current also passes through the already welded portion. That is the loss of current, that is said to be shunting of current. So my dear, this is a continuous welding process. It is used to make the jali like this. You have seen in the kitchen that kind of jalis are there. There also they are connected continuously. So this kind of structures are made using this welding process. It is a continuous welding process. So obviously speed of welding will be more here. And as I said, shunting of current is the loss. Ha, bilkul chili mishra. It would be mentioned in the question. Okay. So my dear, now we are moving to the next process. That is fifth one, high frequency induction and resistance welding. So they are not two different process, actually one only. So here what is going to have, let us say you have this strip of steel. You want to make the pipe of it. Then what you will do, you would be having this strip, this would be having some width and some length. So this width would be made as circumference. You would be just bending it, and you would be, after bending it, just giving input here. Here you are having some mandrel. Okay. And along this mandrel, you will be just bending it and providing it. These are the concave rollers which will be applying some pressure onto this, and they will give this the shape of exact pipe. And when this shape would be provided like this, the shape would be provided like this, then my dear, you need to join this and you will get a pipe. So my dear, steel pipes are made by this process, and seamless pipes are made by centrifugal, true centrifugal casting. Okay. So if you are going to join this, what is going to happen? You would be having this sheet like this. Here you will provide some positive, here you will provide some negative. Then my dear, when this will be getting joined together, my dear, because of the current produced, the weld is going to be happen. Okay. So my dear, this will help you to make that kind of pipes. And my dear, generally they have a length of 20 feet which are available in the market. Like Jindal Industry made that kind of pipes. Many others are also there. So when you will get these types of pipe, they are having generally a length of 20 feet. So my dear, now if you are going to provide the conductors and using the direct current, we will call it as resistance welding. If you are going to provide the inductor coils and using AC, we will call it as induction welding. Generally, we are going to provide high frequency of alternating current. Sir, is there any term repercussion welding? Okay. Dear, I feel you have written the name not correctly. Percussion welding is there. Okay. So that percussion welding is not a type actually. That is depending on the process. If the finishing is happen better, then we are calling that. Okay. If you want also, I will share it to you. Okay. Percussion welding is the name which is used. So my dear, here if you are going to see, we are using the copper conductor here. Here and here copper conductors are there. This is the mandrel which is used to make the cylindricity of the pipe. Okay. This is used to make the cylindricity of the pipe. Current used is 100 kilohertz to 500 kilohertz. This is the frequency of the current we are using. Okay. Seamless pipes are made using centrifugal casting. We have already seen. So here my dear, we are making it and we have completed the resistance welding process. Now we are moving to the solid state welding process. In solid state welding process, the first process is explosive welding. So as here I said the solid state welding, it means here melting will not happen. So my dear, we would be having a workpiece which would be treated as a target plate, and we would be having a flyer plate which is always thin than the target plate, and this is something I want to be welded over it. Always flyer plate is thin. Then my dear, here we are going to use explosion. So we need to use some explosive material. So we could provide this explosive onto this thin plate known as flyer plate, but when explosion happen, there are chances that the surface will get blackened. So to avoid the blackening of the surface of flyer plate, we are providing a buffer plate in between. This buffer plate generally is made up of rubber. As you know, rubber is having excellent damping capacity. So my dear, generally this buffer plate is provided in between. Now detonator is required to start this explosion. So when detonator is starting, then explosion will happen. Because of that explosion, a very high pressure wave, energy wave is getting created. You must have seen in the movies where these kind of scenes are shown, where some blasts are shown. Like there was a movie where Akshay Kumar was also there. I do not remember the name. It was 26, Special 26, whatever it is. So in that movie, when the blast happens, then that actor or whatever the person near that blast is there, they are shown like they are just moving in the air like that. So they got some pressure wave. Because of that, they got a very high kind of shock, and because of that, they go to a very far distance. So my dear, similarly, that pressure wave will be given to this flyer plate. Because of that, this flyer plate is becoming in the semi-solid form and going to connect onto this workpiece. You are providing this angle which will decide the direction of welding. You are providing this initial distance known as standoff distance. This is provided for initial impact. Numericals are coming from. Okay. Fine, let's move further. So my dear, when we are talking about, so in South movies they are happening more, but in South movies this is not happening because of blast. This even happens from the fightings, but in Bollywood movie it happens only in the case of blast. That is the difference, Amir. So I would also like to tell you guys that whatever the numericals are coming, they are basically from arc and resistance welding. From other topics we are not having numerical. This is just application you need to remember. So when we are having this welding, here one very important point which is already asked in the GATE paper, the speed of this welding process is limited by the speed of sound. The relation between them is because of this explosion. Okay, so there it would be having a limit from speed of sound. So my dear, when we are talking about this type of process, okay, here generally diffusion is going to happen. So one material is getting diffused into other. Whenever we are talking about the diffusion, it is like you must be knowing that if we have two gases in this container, A gas is here, B gas is there. If you remove this partition, then both the gases will get diffused into each other. So that kind of thing is said to be diffusion, which is going to happen in this type of welding. The second type of solid state welding is friction welding. And my dear, if you are going to see the application of this, this is in whenever you are going for cladding of cylinders. For cladding process, we are going to use this. For cladding process, explosive welding is getting used. Friction welding is used whenever we are going to join drill bit with the shank. This also have already been asked in the GATE exam. What is the application of friction welding? So when drill bit is connected with the shank, that process is said to be the friction welding process. So my dear, here also we would be having two things. One is a rod A, other is a rod B. So my dear, this rod A is rotating with some speed of omega, and this rod B is going to be stationary. Okay, this rod B is stationary. You are going to take this rod B towards A. So A is having some motion, B is stationary. So when both of them will be connected, initially A is rotating, B is at rest. So because of that, at the interface there will be some relative motion. Relative motion means conformation of friction. So because of that, obviously the friction, what it does, friction tries to convince both the bodies. Friction will try to stop A and try to rotate B. So as you are overall all the time giving the speed to this, definitely friction will not be able to convince this first body. So friction will be able to convince the second body, and after some time both will be rotating with the same speed. So during the time when friction is there, a lot of heat is getting produced between the surfaces, and because of that heat, diffusion welding will take place, and here also melting will not happen. So it is a kind of solid state welding process. So my dear, this is used for drill bit and shank. So my dear, if you have both the materials of same, then my dear, you will be having this type of weld bead if you have both sides same material. But if the material is going to be different, if same material are there, this type of weld bead would be happen. If you have different material, then hard material will not be showing any kind of deformation. Soft will make a layer over it like this. Okay, so this is going to happen. So in case of drill bit and shank, shank is going to be soft and drill bit is said to be hard material. So we would be having this type of weld bead geometry. So moving to the next process, guys, the third solid state welding process is ultrasonic welding. So as the name suggests, we would be using the ultrasonic energy of vibration. So here, these are workpiece 1, this is workpiece 2. They are placed together, and here we are having some HSS tool tip. There is some clamping arrangement which is going to provide sonotrode which transfers the vibration to the tool tip. Vibrations are produced in the transducer. So in this transducer, vibration will be produced. Those vibrations transfer to the HSS tool tip with the help of the sonotrode, and due to this vibration, the weld is going to produce between the workpiece. Pressure is applied from the anvil side also. Anvil is a kind of support which is stationary. And my dear, here, as you are not using a lot of energy, as I said, here this kind of welding can join very small or thin elements, and it is used in electronics industry. If you want to join ICs, if you want to join some kind of diodes, some kind of transistors, so those kind of elements. So in the electronic industry, this process is used where we need to weld very small electronic components like IC, like transistors, like, or you can say that diodes. Okay, so that is the application of ultrasonic welding. So others we have already seen. Now we are reaching to the gas welding process. Gas welding process is a kind of chemical reaction type of welding. It is a kind of chemical reaction type of welding, and gas welding have a generalized name. This is important for theory point of view. So my dear, generalized name of this welding is Oxy-fuel welding. Here oxy indicates we have oxygen cylinder, fuel indicates we have some fuel cylinder. That fuel can be acetylene, that fuel can be acetone, that fuel can be methane, fuel can be propane. So whatever the fuel we are going to use, the name will be changing based on that. If you are using hydrogen, it is oxy-hydrogen welding. If the fuel is methane, oxy-methane welding. But in general, what we study is we have acetylene. So we will be calling it as oxy-acetylene welding. So my dear, when we are talking about oxy-acetylene welding, C2H2 is acetylene. So my dear, when we are going to use this, the principle of this welding process is nothing but the combustion. So in the combustion reaction, whenever the fuel is reacted with oxygen, it gets converted into CO2 and steam. CO2 and steam are the byproduct of such reaction. So my dear, when this C2H2, which is acetylene, this will be reacting with the oxygen, it is getting converted into the CO2 and steam, because water will not be in the liquid form, and a large amount of heat is getting produced. This heat is going to be used for the welding process. Then I feel you all are aware that this C2H2 when react with oxygen, you will get 2CO2 plus H2O plus heat. You must be thinking of that, sir, how this reaction is happening. 1 mole of acetylene require 2.5 mole of oxygen. If you are going to provide 2.5 mole of oxygen, you will not get any kind of flame, arc or spark, because it would be a complete combustion which happens in the IC engine. But we also require some kind of flame, some kind of spark which can be used for the welding process. So my dear, for that purpose, when we see this reaction, this reaction is going to happen in the two stages. So in the one stage, C2H2, when it is going to react with the oxygen, it will be converting into carbon monoxide, H2 plus heat. Then my dear, this is 2CO. Then my dear, 2CO plus H2, when it is reacting with 3/2O2, it is going to give you CO2 plus H2O plus heat. So my dear, you are getting heat 2 times in 2-stage reaction. So my dear, this heat 1 and heat 2 when we are talking about. So my dear, these are the two kind of heat we have seen. So these two reactions are denoted by two flame. This first reaction requires 1 mole, second reaction requires 1.5 mole. We never provide 2.5 mole of oxygen. We always provide lesser amount of oxygens. Why? Because when you are not given the proper food at home, you will search for the food from outside. So my dear, similarly, we are going to have a torch. So when we are going to have this torch, in which acetylene and oxygen are provided from the cylinder. So if oxygen is provided in insufficient amount, then to take the extra oxygen for combustion purpose, my dear, fuel is coming outside. So that fuel is coming outside in the form of the flame. So my dear, stage 1 reaction will give smaller flame, stage 2 reaction will give large flame, because here more need of oxygens are there. So these reactions are not going on separately, they are going on simultaneously as fuel is coming continuously. So when these reactions are happening, here also not complete oxygen provided, here also not. So two flames are coming from two reactions. Inner flame is having lesser surface area, outer is having more surface area. So this heat and this heat, when we compare, any heat can be more for different fuel. But temperature of inner one is always more because of lesser surface area. So when heat is getting distributed over a flame, then its temperature is also going to increase. So my dear, for this smaller flame, we are always having more temperature. So due to more temperature of the smaller flame, always the inner flame is going to be used for the welding purpose, and outer flame is used for the preheating and post-heating kind of work. So my dear, you can see here we have inner white cone and outer bluish cone. So two types of cones are there. So this inner cone is traveling some distance n, and my dear, this outer cone will be traveling always the more distance. Okay. So my dear, now we are talking about, this is first type of flame which we are actually there are three types of flames are there. One is said to be neutral flame, other is said to be oxidizing flame, and third one is said to be the carburizing flame. Okay. So when we have these three types of flame, how we are deciding it? So my dear, you know 1 mole require 2.5 mole of oxygen. So we are never providing that much. Thanks Chili for your wonderful words, but don't worry, right now take the benefit of online. So when we are talking about the neutral flame, we are going to provide acetylene and oxygen in the ratio of 1:1. Means for 1 mole of acetylene, we are providing 1 mole of oxygen from the cylinder. Then my dear, when we are talking about oxidizing flame, here we are providing more oxygen, not from the requirement, but more from the acetylene. So we would be providing around 1.15 to 1.6 times of oxygen than the acetylene. And here you would be providing 0.7 to 0.8 times of oxygen than that of acetylene. So in all the flames, we are providing oxygen lesser than the fuel only. So my dear, if we are having the neutral flame, this is the neutral flame. For the neutral flame, we are going to provide C2H2 but a O2 in the ratio of 1:1. So my dear, for that, N is the distance travel by this flame. Okay. So my dear, the temperature here we are getting 3260 degrees Celsius for the inner flame. Then my dear, we are also going to have the second type of flame which is oxidizing flame, where you are providing oxygen amount slightly more than that of the acetylene. Here temperature is 3380. As you are providing more amount of oxygen from the cylinder, this time the distance traveled by the flame is lesser. It is around 0.52 or 0.332, 0.5 times of the N. If in the neutral flame it was traveling N distance, here it is traveling 0.33 to 0.5 times of N. Okay. So my dear, if that is the case, that is the traveling distance, my dear, 0.33 to 0.5. This time the temperature would be more, because the flame size is surface is going to be less. Thanks Amir for your wonderful words. So that is why the temperature would be more. So my dear, generally oxidizing flames are used for the alloys like brass, bronze and all, and neutral flame is used for the normal ferrous materials what we have seen. So my dear, there is one more exception when we are talking about the brass. Here some zinc is present. So whenever we are going to weld this brass with the neutral flame, zinc is having very less vaporization temperature, so it gets vaporizes, and if you don't want it to vaporize, we are going to weld it from oxidizing flame, because here more oxygen is present. So zinc will react with oxygen and will make ZNO. Vaporization temperature of ZNO is quite more than that of zinc. So because of that, ZNO will make a layer over the weld pool. So because of that, zinc will not be vaporizes, and in that case you can save your zinc inside. So brass is generally welding using the oxidizing flame. Then my dear, when we are talking about the sounds, in the neutral flame we are going to have hissing sound, like you have seen one movie was also there, kind of. Okay. Similarly, oxidizing flame will give you roaring sound. Roaring sound is there. But my dear, carburizing flame is a silent flame. There no sound will be coming. So in carburizing flame, my dear, you are providing that much less oxygen that this time fuel itself comes outside to take the oxygen. Because of that, some acetylene feathers are going to form, which is traveling the distance 2 times the neutral flame, because of which temperature reduced to 3060 degrees Celsius. Carburizing flame is generally used for welding of cast iron or high carbon steel, where carbon amounts are more. Otherwise, if you would be welding low carbon steel using this flame, then it may absorb carbon. It may absorb carbon from acetylene feather. Okay, so we are using those elements which are already saturated with the carbon. So carburizing flame is used for cast iron, for high carbon steel, that kind of elements. Okay, so guys, just like and share the session. We are already at the gas welding we have completed. Now we are reaching to the allied processes. Some other welding processes are pending that will be coming, electron beam welding and all. So this is allied processes where we are talking about soldering, brazing and braze welding. Okay, for this I am taking this table because questions are generally coming from this table. So my dear, when we are going to have the mechanism used for soldering is adhesion. Here also adhesion, here also adhesion. If we are talking about the temperature, here temperature is less than 427 degrees Celsius. Here temperature is more than 427 degrees Celsius. Here temperature is more than 427 degrees Celsius. Here the filler material, actually in this process what we are talking about, allied processes, they are neither said to be solid state welding nor liquid state welding. They are said to be actually solid liquid. Why it is said to be? Because here parent metals are not melted, but filler metal is melted. So you would be having two materials, like let us say I want to join these two things. They are in solid format, but the filler material by which I am going to join them, that would be in liquid form. So that is why solid liquid state welding it is. So my dear, that filler material by which we are joining, here we are using lead plus tin in soldering. Here we are using copper plus zinc, which is brass, in brazing, and copper plus tin, which is said to be bronze, in the braze welding. Braze welding is a kind of welding process only. Soldering and brazing are slightly different from the welding process. Generally, braze welding using the gravity force for the filling of molten metal. On the other hand, soldering and brazing are using the capillary action for the filling of the gap. So that is the major difference. So for capillary action, the gap between them should be very, very less. Then only capillary will happen. Hi sir, I have to revise machine design. Yes, Dhruv, marathon would be sufficient because 8 hours marathons are definitely going to give you a quick revision. The problem is only one, that is the practice. So for that also I have already planned for you. On the same day when I will take the marathon, I will take a practice session also. And tonight also, if you want, you can join me for the practice session of machine design. So I will be teaching from very basic everything. And if you are going to join it, it would be enough. At least it will be enough for 80% of the marks in the GATE exam. Shreyas, we are going to complete it within next 20-25 minutes. As per the promise, 2.5 hour session it is going to be. Okay. So let's move further. So guys, the application when we are talking about, so for electrical and electronic circuits, we use soldering. For hydraulic circuits, we are going to use brazing. And my dear, when we are talking about the braze welding, here we are going to join the plates like welding only. So my dear, when we are having different types of welding technique, first is said to be forehand welding technique. When you are moving towards non-welding material, welding to non-welding part. So here, my dear, outer flame will reach first and inner flame will be reaching second. So because of that, here outer flame is going to do preheating. So it would be removing any oxide layer if present. Preheating, it would be increasing the temperature to some extent so that directly the temperature will not go to the welding temperature. So cracking defect will reduce. There would be no hot crack, cold cracks would happen, and there would be no oxide layers will also be present. Then my dear, this is also said to be forehand welding technique, and it is used for horizontal and vertical type of welding. So my dear, when we are using backhand technique, in this case flame is going from welded to flame is having you can say flame is heading towards the welded part. Previously flame is headed towards the non-welded part. So here my dear, you can see that first of all inner flame will reach, then outer flame will reach. So outer flame will be going for post heating this time. Post heating will help us in relieving of thermal stresses after the welding process completed. Okay. So once welding is over, we need to remove the thermal stresses. For that, we would be having the outer flame. Inner flame is used for the welding purpose. For horizontal and overhead joint, we are using this backhand technique. Then my dear, the angle made by the torch axis with the horizontal is said to be the torch angle. And this torch angle is said to be 90 degree in the start of welding. It is 0 degree at the end of welding. During the welding, it would be lying between 0 to 90 because in the starting we need more heat to be concentrated. Okay, so I am going very fastly because they are not very important things. My dear, if you are not going to provide the oxygen from the cylinder, then entire oxygen required for welding would be taken from the outside. Such processes are known as air acetylene welding. And in such case, we are reaching to this temperature only because flame length is increasing, temperature would get reduced. And my dear, and when we are talking about this, here for complete combustion, entire oxygen is taken from the outside air. That is why temperature is very, very less. It is used as the heat source for the soldering process. Then my dear, we are talking about radiation. Okay, radiation energy welding, radiant energy welding. Okay, radiant energy welding. So my dear, here we have electron beam welding first. So as the name suggests, welding would be happening with the beam of the electrons. So here my dear, first of all, you would be having a tungsten electrode or some kind of electron gun here, which is cathode. Then my dear, here we would be having a cup shape. Okay, here a cup shape cathode. Okay, I am making it separately. If I make this figure, So you would be having first of all a tungsten electrode, which is said to be electron gun. Then we have a cup-shaped cathode. Okay, this is the cathode. Then we have an annular anode, which is having some hole in between. Okay, so what is going to happen, as you are going to provide here the power source, so electrons are coming from here out, then electrons are repelled by this cathode and attracted towards anode. But when it is like in some of the ad, have you seen some ad where it was a ad for like actress and actor are there. Actor is standing like this with open hands, open arms, and actress is coming towards him. And when actress is coming towards him, at the same time actor has to hold his pant, so actress goes down. That kind of ad once was there on the television. So similar thing is happening. This annular anode is calling the electrons, but when electrons are coming, it is having holes, so those electrons are attracted very fastly towards the anode, and when they come, they are going to pass through it because it is having some holes in between. So my dear, when these electrons layers are going from this anode, we are going to have some focusing lens which are going to help us to focus these electrons at the welding region. Now my dear, these electrons, if they are going to collide to the workpiece surface, they will give their kinetic energy which would be used for the welding purpose. So that is why we need to take care that these electrons shall not collide with the oxygen, otherwise they will lose their energy and welding will not happen. So that is why we are going to provide vacuum. And when these electrons are going to collide over metal surface, X-ray gets generated, which are very harmful for human being, which can create cancer. So to avoid that kind of thing, we need to make this setup lead lined. Lead is going to absorb the X-rays. This is going to be used for welding of super alloys. And here the kind of weld produced, they are very deep. They are very deep and thin. So my dear, the width to depth ratio, this is depth, this is width. So width to depth ratio is generally 1:3. So whenever these welds are going to produce, their width to depth ratio is very, very high. Generally, they are deep penetrated welds are produced. So deep penetration, and they are having very good quality. So this is EBW process. Now my dear, you can see the application of this process is joining tungsten, titanium, nickel, cobalt, stainless steel, beryllium in aerospace application. Moving to the thermite welding. Thermite welding is the second type of chemical reaction welding. And is it also used in space? Dear, it is not used in space, but used for aerospace applications. Okay, for aerospace application it is used. So when we are talking about the thermite welding, once again the second type of chemical reaction welding. In the country like India, which is not a developed one, it is a developing country. So in the developing country, what is going to happen, dear? So in the developing countries, my dear, we are having the railway network at the places where even jungles are there. So we don't have the setup for flash butt welding where 1 lakh ampere of current would be coming. So there, what we are going to do actually, for such cases, we are using this process, thermite welding. For that, we just need some basic thing which an engineer is always having. One lighter is there, we have. One pudia is there where we have thermite mixture. Containers are available generally everywhere. So what we are going to do, we are going to have a container. In this container, we would be putting the thermite mixture. Thermite mixture. And my dear, we would be having the matchbox to start the reaction. So this thermite mixture will be having aluminium and Fe3O4. This is the thermite mixture. So my dear, when we will be having this thermite mixture Fe3O4 and aluminium, and generally if I see the ratio Fe3O4 and aluminium, it is provided into 3:8 ratio. So we are going to have this mixture, and when they are going to react with each other, then Al plus Fe3O4 these are 3, these are 8. You will be getting 9 iron plus Al2O3. It would be 4. So this is what you are getting. This is the molten steel. So this is the molten steel which turns to boil, and this molten steel is heavier and this slag is lighter. So we will be removing this lighter layer of slag which is coming at the top, and rest molten steel would be poured inside the gap of the two rails, and the weld will be getting produced. Is it clear? Dear, I will share. Amir, I will share that. Sir, deep penetration, then heat affected zone. No, Shri Arvind, deep, actually in electron beam welding process, the speed of welding is more. So that is why here also heat affected zone is less. Because very large amount of heats are coming. If you want to know in the electron beam welding, I would like to say that we are going to provide 80,000. 80,000, that much potential difference is provided. So 80,000 electron volt kind of potential difference is provided, and it is restricted to 1.5 lakh. 80,000 to 1.5 lakh we are providing for welding, and it is going to 2 lakh for the cutting purpose. So because of that, it is a continuous process which is happening very fast. So because of that, speed high, heat affected zone will be lesser. Okay, so that in general already I told you, that's why I didn't say that point. So when we are going to have this process, we just need to pour that molten steel into the gap of the rails, and weld will be produced. So that is the beauty of thermite welding process. It is second type of chemical reaction welding process. Okay, so my dear, this is used to join railway track on site where we do not have availability of very large and heavy equipment. So all these welding process are shown in the table. We have seen explosive ultrasonic friction, submerged arc welding, shielding metal arc welding, TIG, MIG, plasma arc welding, electro gas, everything we have seen. So all these are shown in this table to show you the classification. One is solid state welding, other is liquid state welding, other is solid or liquid, then radiant energy welding. Okay, so all these things we have already discussed. So my dear, thermite welding also we have already mentioned this. So this is steel turned boil provided into the gap, and welding will take place. Next is atomic hydrogen welding. This is a special welding process which is a combination of two, and this is not coming in any of the category. In this we are providing this hydrogen gas and we are providing these electrodes. So when hydrogen gas is going to provide with these electrons, some arc is provided that is getting broken into hydrogen positive and hydrogen negative ions. Okay, so hydrogen gas is broken into the ions. Now my dear, for that energy is provided by the spark. Now hydrogen ions are unstable, so they will once again react with each other and provide H2 plus a large amount of energy is generated. This energy is used for the welding purpose. So my dear, some people may be asking you one question, like I always ask, being an interviewer all the time, this question, that when it is happening, why we are not directly use this energy for welding, why we are using this one? Some people say this energy is more than that. Then I say, wonderful, why you are looking for any job? Just do this work at your home. Break hydrogen, join hydrogen. Every time you will get some energy. This is against the energy conservation. How you are getting more energy? This is not fusion or fission happen. In fusion you get extra energy. There it is not fusion. Hydrogen is resulting into hydrogen only. So no fission, no fusion is going to happen here. In fusion, fission we get some other element. So my dear, the reason for this is something different. And Amir, the reason for that is there in the heat transfer. When you study heat transfer, you must have seen a curve between conductivity and temperature. And there these three lines were provided. This is for the air, this is for hydrogen, this is for helium. Helium is costly, so we are not using it. So if you see the hydrogen, you can feel the conductivity at some temperature is going to be more for hydrogen than that of air. So if we are going to use hydrogen environment, more heat would be supplied to the welding and efficiency of the process will be high, because heat loss to the surrounding will reduce. So that is the reason why we use this. Otherwise, you are going to say whatever the energy difference is wrong. Energy is not different. Energy reaching to the surface is different. Okay, so I feel Amir, now you got it. So the reason for that is this: already at welding temperatures are higher. So at high temperature, hydrogen is more conducting than air. So that is how we are using it. Okay, that's why I mentioned also there is nothing like fusion. Okay, this is not going to happen. Exothermic reaction is the process. This reaction is exothermic reaction. So my dear, moving to the next, atomic hydrogen welding we have completed. Okay, so all these things we have already seen. So my dear, these are the faltu things which are never going to come in the examination. These are the symbols of weld. So I will provide you these PDF. Now whatever I have these things, they are not something which I will teach you, because they are to remember that these are the notations of symbols. Okay, how the welds are shown like this. Okay, fine. So let us move to the next. Okay, so moving further, guys. Now my dear, we are talking about welding defect. Spatter we have already discussed. Spatter defect we have already discussed. Then my dear, heat flow characteristics. So my dear, when we have heat flow during welding process, there are two types of heat flow formulas are given. This is for 3 dimension. This is for 2 dimension. You know, heat flow happened during the welding process. No issues, Aniruddha. I know you guys are having some other classes also. Huh. Amir, don't worry. Today we have that. Okay. Don't worry for that. Okay. So just wait. Yes, I'm continuing. Just wait. Fine, guys. So these are the formulas for heat flow characteristic. They are also not required for gate. For gate, you can leave them. Still, I am showing the formula. Never asked in gate till now. May come, but till date it is not. Okay. So my dear, when we are talking about this, if we are talking about this, I would like to say that whenever we have the spot weld, so for the spot type of welding, this is a kind of sphere. So we are assuming this would be acting like a heat source in 3 dimension. So for the spot welding, we would be using this formula for heat flow characteristic. But in case of the butt weld, like when we have butt weld, so it is like a line. So that would be considered as a 2-dimensional, where heat is going to flow in 2 dimension like this. So for butt weld, we will use this. For lap joint or spot weld, we will be using this. Here, my dear, these parameters are explained like theta m is the temperature difference. Okay. Then, my dear, you know, VW is the weld velocity, alpha is the thermal diffusivity. So all these things are mentioned. Q is the heat rate. Rate heat means what will be the limit unit. H is height of bead, width of bead, conductivity, melting point, then welding speed, thermal diffusivity. Okay, so these are the parameters. Now there is a term known as duty cycle, which is very, very important. While solving welding problem, I come across the designation standard of welding electrode. Dear, actually that is in P&I syllabus, not in mechanical. So we are referring mechanical syllabus only. Okay, so PI syllabus it have. So that question will be in PI, you can check it. Okay, that is from production industrial paper. So my dear, when we are talking about duty cycle, as in the electro-slag welding, you also have seen that after some time we stopped the arc and welding was happening without any current. because of already presence high temperature. So duty cycle is defined in such a way that the time for which you are continuously switching on the arc, it is also defined as arc time by weld time. Generally, a standard of 10 minutes of duty cycle is defined for universal. For India, we defined it like 5 minutes. Okay. So when I say 10 minutes as standard, 10 minutes would be considered as 100% duty cycle. So if someone say 5 minutes, I will call it as 50%. So the I square into D is going to be constant. So duty cycle is nothing but the time for which you are continuously providing. Okay. So my dear, if that is the case, I square D is equals to constant will be used. The question will be like, for 1000 ampere current, duty cycle is 40%. Then for 600 ampere current, what would be duty cycle? So what you would be doing? You would say 1000 ka square, I square into 40 is equals to 600 ka square into what? So whatever you will get here, this would be the value of duty cycle D2. This type of question can come in this. So my dear, next defect is arc blow. Welding defect is arc blow. So my dear, what is going to happen if you are going to weld this plate? During the welding, current is flowing. Because of current, magnetic field is generated across the electrode and workpiece. So my dear, whenever you are going to start the weld, there are chances of deflection of or deviation of arc because of this magnetic field. So because of this deviation, we can have the defect like scattering of molten metal. If you want to avoid that kind of defect, we are going to provide some extra plates so that this deviation should not happen, which is tab in and tab out. The chances of arc blow are more with DC, less with AC. Okay. So that also you guys have studied duty cycle and arc blow. So my dear, now we are moving to laser beam welding. In the laser beam welding, the principle is, if we have atoms at some low energy, when some energy is provided with the xenon lamp, these low energy atoms would be going to the high energy. It doesn't mean that atoms are moving like that. I want to say their energy will increase. So when energy is more, everybody wants to be at a lower energy state because there he face more stability. So when you are going to provide the energy, they reach to high energy. Then they are feeling instability. They try to reach to some metastable state and they release some energy in the form of photons. That energy is used for the welding purpose. So we are calling it as laser beam welding. Okay. So my dear, how it is happening? This is the xenon lamp. Here we are having the pumping zone. So here we are providing some powder. So because of the amount of heat coming from xenon lamp, it would be going to high energy region, will leave some kind of photon. And when those energy light will be coming, this surface is 100% reflective, which will 100% reflect the light. This is 98% reflective, which will allow 2% to come out, which would be coming straight. Okay. So when it would be coming straight, it would be colliding with the mirror, which will be directing it towards the lens, which will convert it to the welding area. So in laser beam welding, we need not to go for any kind of vacuum pump. So cost of this is less. Here no X-rays are produced. It is lesser harmful. So it is more preferred over electron beam welding and can be used for all those applications of electron beam welding which we have seen. So laser beam welding can be used for all of them. Okay. So my dear, this is something known as laser beam welding. For this, you are using two types of laser. One is ND-YAG. Here ND represent neodymium, Y for yttrium, A for aluminium, G for garnet. Okay. So my dear, these are the numericals. So we are not doing numerical in this session. For that we have a separate practice session. Okay. So my dear, I feel we have completed this welding part. So now I feel we have already completed a lot of time also. I feel this session is going on from 11. So I feel 2.5 hours are completed. Now you want me to cover casting defect today? You want me to cover casting defect today? Because welding is almost completed. I can complete casting defect today, and then next session I am asking from you when you want metal forming, tomorrow or day after tomorrow. When you guys want metal forming, tomorrow or day after tomorrow? Metal forming tomorrow or day after tomorrow? Yes. So there are some theories which I am not covering here because that is something to remember that I cannot help in. Like there are some type of flux coatings. So flux coatings are having some element which will help us to provide the weld bead. They are having some elements which help us to provide their melting point temperature higher. There are some elements which will help us for flame stabilization, which would be increasing their melting point temperature. There are some elements which would be helping us to make them lighter. So those elements are mentioned. Like there are some types of flux coating like acidic, basic, rutile. So all these are mentioned in this. You need to remember the elements in those coatings. So for that purpose, like in acidic coating, we have Fe3O4, MnO2, quartz, silicates. So that I cannot help into. That you need to remember only. Okay. So that's why I am giving you, providing you these slides, but that you need to remember. Yes, that's why I was asking you. My Sunday is, I can dedicate it for you. But the point is whether you can dedicate your Sunday for that or not. Okay, fine guys. So I am just quickly going through the casting defect. Otherwise that is also something you can mug up kind of thing. So in gas defect, first of all, we are having the defects like blowholes, open blows. Okay. So you know my dear, sometimes some moistures are present when the casting is going to happen. So because of that, my dear, we are going to have some you can say holes inside. Okay, like you can see here, these are the holes inside. Why they are coming? If you remember, some gases were producing at the time of casting when molten metal was coming in contact with the facing sand and mould wash. So those gases were coming and those gases were remain inside if porosity of the mould is not good. So inside, if it is present, there were some gaps were there, bubbles were there. So because of that bubbles, we will be having no molten metal going there. So some blowholes would be present. If inside these bubbles are there, we are calling it blowholes. If they are coming on the surface, we call it as open blows. Okay. Then my dear, we are going to have scare. So my dear, when we are talking about the scare, if you are going to have on the surface a very big bubble, in the blowholes it was smaller one. This kind of thing is coming. This kind of thing is coming when the size is bigger for this, and in the blister it is one layer is covering this. So when the layer is covering it, it is said to be blister. When layer is not covering it, it is said to be scare. Okay. And my dear, if some hydrogen gas is present, then you will be having very small hole inside the casting. Then that is said to be porosity or pinholes. We want porosity in the mould but not in the casting. Okay. So now the reason is also mentioned that gas defect which forms inside of the casting are blowholes and surface are open blows. Scare is the shallow blow formed on the surface because of presence of bubble. So if bubble is present on the surface, it will create scare. Inside it will create blister. Okay. And small size holes are created by hydrogen gas, which is said to be pinholes. Okay. Next is remedies. So remedies are, you have to make good porosity of the mould so that gases go out. Second type of things are said to be moulding defect. Okay. So my dear, if your mould is not having good properties, like let us say you are going to have this as mould, but my dear, what is going to happen if at some of the place the sand is not having good strength and some particle of sand is going down from here and this would be reaching to the lower surface like this. So your casting will also solidify in this shape now. So your casting will also solidify this shape now. So this thing is said to be drop because from here sand is getting dropped, and this is said to be dirt because here you will not be having the metal. So this would be the kind of casting you will get. So this defect is coming because of the mold defect. If, my dear, corners are not good and having less strength, for such case your corners may broken and you may be having the casting to be of this shape. So some corners may get broken. So my dear, they are said to be cuts and washes. Once again, a molding defect. Okay. So my dear, for that what you can do, you can convert green sand mold into dry sand mold. It will increase the strength of the mold as well. It would be increasing the permeability of that as well. Okay. You can improve permeability by additives also. Okay. You can improve strength by additives also. So we have seen the molding defects completely. Now my dear, you must have seen riser was doing some of the functions and you were having two types of solidification. One was skin forming and other kind of solidification was a dendritic growth. Other was dendritic growth. So in dendritic growth, we were having the possibility of multiple risers because shrinkages were coming at many places and at all the places you cannot provide the risers. So you were calling that defect as shrinkage cavity. Sir, kal aap bhi okay. ठीक है. Thanks for that. So tomorrow we will not be having that session. Okay, no problem. But tonight we have a practice session of machine design. Tonight at 7 p.m. we have a practice session of machine design where I will solve 15 questions in the class and 15 questions would be given to you as homework. Okay, so this is what we have completed. Okay, sure Venu, sure. For that you will get some video on that. So we have seen those defects. Okay, so my dear, if you have some particle, like you know that if you have some particle to be removed from this, we have seen dirt and drop. Now my dear, when molten metal is entering inside the cavity, it is providing some hydrostatic forces. So my dear, because of these hydrostatic forces, sometimes mold gets some kind of shift. So this molding sand will be shifting by this amount. So my dear, because of that, here molten metal will enter. So it is a kind of, you can say, extra part would be coming on the roof. Similarly, sometimes this can happen in the side wall also. So my dear, this can happen in the side wall also. So this shifting of mold will be happening because of hydrostatic forces. So these defects are said to be scab and swell. Scab and swell. They are happening because of shifting of sand with the hydrostatic forces of molten metal. Here shifting is happening. In drop and dirt, molding sand was eroded and coming down. That is the difference. Okay. Then my dear, fluidity defects are there. Sometimes your molten metal is having improper fluidity. It is unable to fill the cavity completely. So if my dear, like you are having a cavity like this and it is unable to fill it completely and it is capable of filling up to this only, then this defect is said to be misrun. And if there are two molten metal stream are coming like this, one is reaching here, other is reaching here. So this much part remain empty, that is said to be cold shut. So this defect is said to be cold shut. Both are going on because of improper fluidity. So guys, I feel we shall complete it here because likewise I have a lot of you can say things, but these are I feel less important. So I am providing you the handwritten notes for revision purpose if you still want. Otherwise this audio book is there for you all the time. And I will also share this PDF with you so that you can revise it if you want. So guys, here I will say goodbye to all of you. And I will also say thanks for your love and support. So if any one of you is preparing for GATE 24, you can register for the workshop tomorrow. And one more thing guys, marathons are starting from 3rd of January. So you can revise them. I will be sharing the schedule. 3rd January would be strength of material. Yes. You're welcome, Chili Mishra. So goodbye guys for this session. Thanks for joining. We will meet again. So as per your request, we will keep the next session on Monday only. Okay. So goodbye guys for this session. Tonight, machine design practice. Goodbye. Good night. Sorry, not good night. Okay. Goodbye. and happy new year to all of you guys.